Hello everyone, my name is Gaganveer Singh, and in this video I will be demonstrating format task 4.1p of SIT331 Secure Backend Services, which was to implement the persistence layer for the robot controller API. In the previous task, we implemented a full web API solution for managing robot commands and maps. However, the data was not persisted between program runs, which is a limitation for the real-world application. In this task, we will be adding a persistence layer to store and retrieve data from PostgreSQL database. The first step in my implementation was to set up a database to store the data for the application. I chose PostgreSQL version 16 as it is a powerful open source and widely supported database management system. I began by creating a new database called SIT331 using the pgadmin tool. Within the database, I created two tables, robot command and map. The robot command table is designed to store information about the robot commands. It has the columns corresponding to the properties of the robot command class from the previous task. It has an ID, an auto-incrementing primary key, name, which contains the name of command, description, an optional description for the command is move command, a boolean flag indicating whether the command is a move command, created date and modified date respectively. Similarly, the map table is designed to store information about the maps used in the application. It has the following columns: ID, auto-incrementing primary key, columns, the number of columns in the maps, rows, the number of rows in the map, name of the map, description and optional description, created date and modified date. It also has a column named isSquare, which is a computed boolean field that indicates whether the map is square. I have also added some initial data to the tables to have something to work with during the development and testing phase. To connect the database to the API, I use the npgsql.net data provider for PostgreSQL. I added the npgsql package to my project using the .NET CLI command .NET add package npgsql. With the database setup, I proceeded to implement the persistent layer. I created a new folder called persistence in the root of the project and added two files, robot command data access and map data access. These classes contain the logic for interacting with the database and retrieving, adding, updating and deleting robot commands and maps. In the robot command data access class, I have methods for retrieving all robot commands, retrieving only move commands, retrieving a command by ID, a command by name, adding a new command, updating an existing command and deleting a command. Let's start by looking at the robot command data access file. The first thing you will notice is the connection string, which is a constant that holds the connection string for PostgreSQL, like the username, password, database name. The first method, the getRobotCommands method, connects to the database using npgsql connection class from the npgsql package. It then executes an SQL query to retrieve all records from robot command table using npgsql command and execute reader. As the data reader iterates through the result set, I map the values from each record to a new robot command object and add it to a list. Finally, the method returns the list of robot command objects. It uses a select from query of the database. The getMoveCommandsOnly method is similar, but it filters the result set to include only commands where isMoveCommand is true. I made use of where clause of SQL query in this. The getCommand by ID and getCommandByName methods retrieve a single robot command object based on the provided ID or name respectively. The addRobotCommand method takes a robot command object as input and constructs an insert query with parameter placeholders. It assigns values to the parameters using npgsql parameters add with value, including the current date and time for created date and modified date. If the description property is null, it sets the corresponding parameter to db null value. It executes the query using execute non-query and returns a boolean indicating whether the operation was successful or not. The updateRobotCommand method updates an existing robot command in the database. It constructs an update query with parameter placeholders and assigns values to the parameters including the current date, time for modified date. It handles the description property in a similar way as in the addRobotCommand method. The deleteRobotCommand method is straightforward. It constructs a delete query based on the provided command ID and executes it using execute non-query. Moving on to the map data access class. Let's go through some of the key methods. The getMaps method retrieves all maps from the database, similar to the getRobotCommands method. The getSquareMaps method filters the result set to include only maps where the isSquare column is true, indicating that the map is square. Rows equals column. The getMapID and getMapByName methods retrieve a single map object based on the provided ID or name respectively. The addMap method takes a map object as input and constructs an insert query with parameter placeholders. It assigns values to the parameters, including the current date and time for created date and modified date. If the description property is null, it sets the corresponding parameter to dbNull.value. The updateMap method updates an existing map in the database, similar to the updateRobotCommand method. The deleteMap method deletes a map from the database based on the provided ID. Finally, the checkCoordinate method checks if a given coordinate xy is within the boundaries of specific map. It retrieves the columns and rows based on provided map ID and compares the coordinate values against these values. It returns a boolean indicating whether the coordinate is within the map boundaries. With the persistence layer implemented, the next step was to integrate it with the existing web API controllers. Let's start with the robot command controller. In the robot command controller, I first removed the static list of commands that we had in the previous implementation. This was necessary because we are now retrieving the data from the database instead of an in-memory list. I then added a using statement at the top of file to include the namespace for the persistence layer. This allows me to use the classes and methods from the persistence layer within the robot command controller. In the getAllRobotCommand method, I replaced the previous implementation that returned the static list with a call to the getRobotCommands method from the robotcommand.access class. This way, when a client makes a GET request, the controller retrieves a list of robot commands from the database using the persistence layer. I followed a similar approach for other endpoints in the robot command controllers, replacing the logic that interacted with the static list with calls to the appropriate methods from the robotcommands.access class. For example, in the addRobotCommand method, I replaced the code that added a new command to the static list with the call to robotcommand.access.addRobotCommand new command. I also updated the error handling and response code based on the return values from the data_access method. Moving on to the map controllers, I followed the same process of removing the static list of maps and integrating with the map.data_access class. In the getAllMaps method, I replaced the previous implementation with the call to map.access.getMaps. Similarly, for the other endpoints in the map controller, I replaced the logic that interacted with the static list with calls to the appropriate methods from the map.access class. By making these changes, the web API controllers now rely entirely on persistence layer to retrieve, add, update, and delete data from the database. This separation of concerns between the API layer and persistence layer promotes code maintainability and flexibility.